So we have a formula for average acceleration here, which is a change in speed or velocity, and V's are the velocities or speeds. So based on a couple of speeds here and a couple of times to go with when those speeds happen, we can figure out how fast a vehicle is accelerating. And it could be like deceleration too, so negative acceleration. And we are going to take a look at this last part down here. What is the final speed of a car that accelerates at 30 feet per second squared? So they're giving me an acceleration there. That's A. For 3 seconds. All right, so 3 seconds here is probably my T. And if it happened for 3 seconds, like we must have started from 0 and then counted 1, 2, 3, right? For 3 seconds. So I would say T would be 3, and then T0, we counted 3 seconds, we must have started at 0. And the initial speed was 10 miles per hour. And the initial speed is that V0 up there. So that 10 miles per hour is my V0, 10. Now, next thing we have to do is we need to pay attention to the units. They've got to be consistent, and they're telling me velocity has to be feet per second, and time should be seconds. So I have the time in seconds. I'm also asked what must A be, and if in my formula up here, I have feet per second in the numerator of my formula for the V's, and the T's are in seconds. That gives me feet per second divided by seconds would be another way to look at that. When we work with division of fractions, you have to multiply by the reciprocal of the second one. So that'd be feet per second times 1 over seconds. Feet times 1 is feet. Seconds times seconds would be square seconds, which is kind of weird, but that's what it is. And so the response here should have been A is, measured in feet per second squared. And I do have the correct units for A. I do not have the correct units for V. So that means I can't use the formula yet. So the first step there is then going to be to, or actually the second step, because I had to figure out what I was given, is I have to convert miles per hour to feet per second in order to use the formula. So we have 10 miles per 1 hour. And we need to rewrite that by getting rid of what? We need feet and we need seconds. So we have two things to get rid of. We're going to get rid of miles and hours. So to get rid of miles, we multiply by a fraction with miles in the opposite position. And I would like miles to turn into feet. And I can look up that there's 5,280 feet in 1 mile. So that's going to allow me to eliminate miles and get the feet that I want in my goal here. I also need to get rid of hours, so I can keep going here. Hours has to get rid of it, has to be in the opposite position. And I would like hours to be seconds. Now, if you don't know how many seconds are in an hour, you could do minutes next and then minutes to seconds, but I'm just going to go straight for seconds. Because I know there's 60 seconds in a minute and 60 minutes in an hour. And so that means there would be 60 times 60, or 3,600 seconds in an hour. And this allows me to get rid of hours, and it leaves me with my goal of feet per second. The point of putting things in the right spot and canceling them is this tells me that on my calculator, if something's in the numerator, you multiply. If something ends up in the denominator, you divide. And who cares about the ones? Because when you multiply by 1, nothing changes. And when you divide by 1, nothing changes. So on my calculator, I would just type 10 times 5,280 divided by 3,600. So let's see what we get on my version here. Calculator, I've got, oops, I forgot the number, 10, yes. 10 miles per hour. I want to convert to feet per second, so I multiply by 5,280 according to those conversion fractions and divide by 3,600. And that gives me 14.666666667. That's a lot of sixes. So let's see if they give me any rounding advice here. Ultimately, I'm going to round to 1 decimal place, but I'm not quite ready to do that. So I'm going to hold on to a few. Maybe I'll do like 3 decimal places there for now. So I would say that is approximately 14.667 to 3 decimal places. If you want, you can write down all of them for now and then just round at the end. I think that's going to be okay. All right, so now I have more consistent units. So now I'm ready to apply the formula. And let's see, let's read it again. Some scribbles in the way here. What is the final speed of the car that accelerates at that speed? So what they're asking me here is they're saying find, what's wrong with my pen? Find V. So I need to come up with V equals. Fortunately, back here, I was asked to solve for V, and one of those is correct. So let's see which is the correct version here. The correct version on my screen is this one. We went over this one last week. So I can just plug right into that right there. Could I plug into the original and have this work? The answer is yes. It's just like 1 or 2 steps more work because this was already done. So I think I'm going to go with this version of solving it. So V equals A, 30, times T minus T0. So that would be 3 minus 0, close parentheses, and then plus the initial speed, which we had to recalculate at 14.667. All right, let's test it out. Calculator. So I have 30 times parentheses 3 minus 0 if I want to be complete, plus that approximate conversion of 14.667. And so I get 104.667. All right, 104.667. All right, what does that number mean before I continue? Well, I calculated V, and up here it says the V's are measured in feet per second. So that number right there is feet per second. Is that my final answer here? Answer is no, because the problem says, please state your answer in miles per hour. So I got to do a conversion back. So basically I have to reverse what I did up here for the last part. So I need to take that 104.667, that would be feet over 1 second. When I'm doing a conversion, I write things in fraction form. And then I need to get rid of feet and seconds to get miles per hour. So reversing what I did above, feet is in the top here, so it goes in the bottom there, which means miles gets to be switched into the top. So now the 5,280 goes in the bottom, right? Opposite of what I did up there. That changes feet to miles. Getting rid of seconds, since seconds starts in the bottom here, it's got to go in the top to get rid of it. And we're going to go from seconds to hours. And earlier we figured there's 3,600 seconds in 1 hour. That allows us to get rid of seconds and convert to hours. So then the final answer would be the 104.667 divided by the 5,280 multiplied by the 3,600. And again, since this is in the top, we multiply fractions straight across, it gets multiplied by. Since this is in the bottom, it's divided because a fraction bar means divide. So let's see what we get. So my formula said to take this number here, divide it by 5,280, digit, and then multiply, I missed another digit again, 5, 2, there we go. Ah. There, now I got it, times the 3,600. And so I get, now I've converted to miles per hour according to my notes, and it said 1 decimal place, so 71.4 is what I would try here. So I'm kind of running out of room. Let's squeeze it right here. I think that result is about 71.4, and it should be miles per hour. If I got it right. We'll look at that another way in just a second. So that would be what I enter here. So again, I got to pay attention to any given information, how my answer needs to be presented, and then with the given information, I have to use the correct formula. I mentioned earlier I could have used the original formula on this. So let's take a quick look at that. The original formula said A equals V minus V0 over T minus T0. And I was given A was 30 feet per second squared. This happened for 3 seconds, so that means we went from 0 to 3 seconds in the bottom. So T is 3 seconds, and T0 is 0 seconds, so we count 3 seconds. What else? I was given that V0 was, I think it was 10 miles per hour. Which we recognized didn't match the feet per second, so we did a conversion that ended up being 14.667 feet per second. And so now I can plug in this given information directly. So that would give me A is 30 equals V minus 14.667 over 3 minus 0. So it is possible to plug into the original and then find V. We got a little work to do. I can clean up this side a little bit by saying 3 minus 0 is 3. So that gives me V minus 14.667 over 3. But that's all I can do on this side. So now I'm ready to start solving. I would get rid of the 3 in the bottom first, clear the denominator. So that's going to give me 3 times 30 is 90 equals V minus 14.667. And then I could add that 14.667 to the other side. If you take 90 plus 14.667, I think what you're going to get is 104.667. And that is V, which means it is in feet per second, according to the original statement of the formula and how things were measured. So again, I have to then remember the last step is to convert to miles per hour, which we just did before this. Okay. Hopefully that helped.